A NASA spacecraft is set to make history today, getting closer to the Sun than any other human-made object. The Parker Solar Probe must survive the radiation and extreme temperatures it will encounter to solve some of the mysteries about our star. Well, our science editor Rebecca Morell has more. Our Sun in all its fiery splendor. We've been studying it for centuries, but there's still so much we don't know about it now. The closest ever encounter is set to finally shed light on our star. 321Z, NASA's Parker Solar Probe blasted off in 2018, heading to the center of our solar system. It's been orbiting our star, getting ever nearer, but this latest flyby is taking us to a new frontier to touch the Sun. Even though we've had missions that have gone very close to the Sun, that wasn't close enough to get into this sort of magic region where all of this physics and all of these processes that are happening, and that the only way to be able to understand those processes is to fly through them and take the data right where all the action is happening. This mission is breaking records. Parker Solar Probe hurtles past the Sun at 430,000 m. An hour. No human-made object has ever gone so fast. It's the equivalent of flying from London to New York in less than 30 seconds at its closest. It's 3.8 million miles, 6.2 million km from our star's surface. That's closer than any other spacecraft. It will have to endure scorching temperatures of 1,400 degrees Celsius as it passes through the Sun's outer atmosphere known as its corona, and this could solve a long-standing mystery. The corona is really hot and we have no idea why. So the surface of the Sun is about 6,000 or so, but the corona, this tenuous outer atmosphere that you can see during solar eclipses, that reaches millions of degrees, and that is further away from the Sun. So how is that atmosphere getting hotter? The mission is also studying the solar wind, the constant stream of charged particles bursting out from the Sun's corona. The probes even recorded the sounds of the Sun. 3 different types of solar wind: dispersive chirping waves, Langmuir waves, music, and Doctor Who-like whistler mode waves. When these particles interact with the Earth's magnetic field, the sky lights up with dazzling auroras. But this space weather can cause problems too, knocking out power grids, electronics and communication systems. The hope is the mission can help us to better understand this, but first the spacecraft has to survive its burning hot flyby. I will worry, but we really have designed that spacecraft to withstand all of these brutal conditions. It's a tough little spacecraft. During this close approach, the spacecraft is out of communication for several days, so the NASA team face a nervous wait over Christmas before they can finally discover the secrets of our star. Rebecca Morell, BBC News. My goodness, extraordinary story. What a Christmas present. If that all works, let's talk to Dr. Jennifer Millard, astronomer and managing editor at software company Fifth Star Labs, and just explain to us the conditions that this little probe has to get through. It's extraordinary what this probe has to survive. You know, we're talking temperatures of well over 1,000 degrees. It is being blasted by radiation from the Sun, also particles from the Sun. It's being bombarded by dust as well, cosmic dust. It's really the most extreme environment we have ever sent a spacecraft to, but it is as well prepared. It's got its shield, it's got its cooling system, so it should survive. And should it survive? Fingers crossed it should survive. What kind of information do we hope it will bring back? This probe is going to tell us about the Sun's magnetic field in very close proximity to the Sun path, which we've never been able to explore before, and the Sun's magnetic field is so important for us to understand. All of the planets of the solar system sit within the Sun's magnetic field. It influences as all of the planets, you know, life on Earth as well. It's going to sample the solar wind. So this constant stream of charged particles emanating from the surface of the Sun, we don't understand how the magnetic field of the Sun is created. We don't know where it comes from, and we don't understand how these charged particles start almost stationary on the surface of the Sun and then they're accelerated to 1,000,000 miles an hour. And we need to understand this because they make up space weather, and space weather impacts our life on Earth, not just with the beautiful northern lights or the southern lights, the aurora, which we've enjoyed so much this year, but also impacts our satellites. A really strong solar storm, when we have a big explosion of material on the surface of the Sun that barrels towards Earth, well, that can even knock out some of our satellites. It can pose a danger to astronauts in space as well, and we rely on, you know, satellites for not just studying space, but it's looking at our planet. It's monitoring weather, natural disasters, communication, navigation with the GPS network. So understanding the Sun and how it works is absolutely vital for modern life, and if once we get that kind of understanding, I mean, obviously there's No controlling of these solar flares, these winds, but what will that information mean logically for us in terms of those satellites, GPS and everything else you've described? Well, it means we'll be able to make forecasts, so like we can predict the weather on Earth. It would be amazing, and if we could forecast space weather and say, okay, we know that there's going to be a storm in 3 days, which satellites might impact, let's put them into safe mode, maybe we can move their orbits, move them out of the way, we can get astronauts into more sheltered parts of space stations, or if they're on deep space missions, we can give them warning, because we're moving into the era now of not just sending astronauts to the moon, which is what we're hoping to do with Project Emus, but in the next couple of decades we're looking to send astronauts to Mars, and on that sort of journey you're 8 months in space, there is going to be a solar flare, something is going to hit you, and we need to give those astronauts as much warning as we can to make sure that they're protected, so having that ability to predict these storms would be essential. So a lot riding on this little probe. No pressure there. Dr. Jennifer Millard, astronomer and also off from the Fifth Star Lab software company, thank you very much for talking us through it.